Welcome to Industry Insights with AIM Solder, a video and podcast series where we dive deep into the world of soldering and electronics assembly with the industry's top minds. I'm your host, Gail Towle. Talking for the third time with none other than Dave Hillman. Dave Hillman has been in the field for over 3 decades, maybe 4 decades-ish.
Long time.
A lot of time at Collins Aerospace, a lot of time working with industry organizations, and that's actually what we're going to talk about today. So there's a lot of really good industry organizations out there. Some of the top ones are SMTA, the Surface Mount Technology Association, and IPC, which stands for, is that Institute for Printed Circuits?
Correct. We're not supposed to say that anymore, but that's the only one that makes sense. You know, IPC is kind of like KFC. We just don't say what the acronym is anymore. So, yep, Institute of Printed Circuits.
And then there's also consortia like INEMI, which also stands for something, and and other ones as well. So you've been deeply involved with a lot of these organizations throughout your career. Can you talk about what initially drew you to participate and how you got started in these groups?
I came out of General Dynamics and doing structural materials. So when I got to Rockwell Collins, I knew nothing about the electronics industry. And my mentors, the very first thing they said was, you'll be going to the IPC and the SMTA meetings. I said, okay, what are those? And they had been involved for a long time. And I asked, why do we need to be involved in this? And they told me 3 things. They said, 1, you're going to network. You're going to meet other people in the same position as you doing things in other companies. And because we have a small network, small industry, that networking is very special because you can call most of the people you can call up, and we won't talk about proprietary things, but the general knowledge stuff you may not know that they do. Most people are very giving of their time and knowledge. And so number 1, you're going to create a network. Number 2, you're going to grow yourself. You're going to become more comfortable in public settings. When you sit down at the dinner table, which is a salad fork, but which is not everybody comes from households that was taught and you learn that. So you're going to be immersed in this whole industry setting and just how that all goes. And the other is you're going to learn about the industry specifications. And, number 1, you're there to represent your company, but number 2, you're there to make the industry better. And how can you make those 2 things, instead of being mutually exclusive, how can they be collaborative? Without, you're being paid to go by your company to participate, but you don't have to make it only fit Rockwell Collins or Lockheed Martin or Raytheon. It can be something that the whole industry uses. And the one thing that I learned out of this is that anytime we change an industry spec, it costs us money. It costs everybody money. And so we're all working for the same goal. We're trying to have requirements that make sense, that are uniform across the industry, that make our products better. And, John Hagee, John Mather, who are my mentors, were heavily involved in the industry consortia and in IPC and SMTA. And I went and, put my hand up and said, I'll help write something. And writing led to being on a committee. And then from being on a committee, it led to being a vice chair, and that led to being a chair. And 25 years later, it's like, wow, okay, I'm involved. So great organizations, like you said, from both SMTA, IPC, also the industry consortia, just a world of growth for an engineer.
So that sort of leads into my next question, which is, why do you believe it's important for professionals in the industry to get involved in these organizations? Why should a new engineer or someone consider participating?
I think the biggest, there's personal growth, but the other thing is uniformity. We have customers who don't sit in these meetings. They don't go to the consortia. Lead-free is a good example. Oh my God, if we have lead-free, we get tin whiskers. Do you know about the GIA specifications? The 2 committees that have put out the national standards on how to put a lead-free control plan and how to mitigate tin whiskers. Do you understand that they have put science into those, that the mitigations that are listed in there, what's prohibited is not prohibited, have been vetted through a committee? And we don't always agree. Sometimes in committee we don't, but there's a lot of consensus in these documents. And that way the customer doesn't have to be completely knowledgeable. They can look at an industry standard, and it just makes consistency. The one I always like is, well, does it meet J Standard 1? My answer is, does it exceed J Standard 1? Because when you look in the front part of the specifications, excuse me, almost any industry specification organization, these are the minimums you need to meet. Just because it meets J Standard 1 in a certain application, you need to go farther. And so when people just take it and we'll just meet this, that's not fully understanding what the committee has tried to provide to the industry. So being part of that, you understand new technologies. You see, like when ball grower arrays came in, what are we supposed to do with these? What are the workmanship requirements? Oh my goodness, there's a void. Now what do we do? And that first came up in committee because different companies would ask questions. Hey, you don't have a requirement for voids. Does it matter? And then we'd start talking about it. And then we decide, well, is it an issue or not? Is there data behind that supports that? Have we documented that data? Is it published? And so it just being part of committees, being part of consortia allows you to grow, but also understand that interaction of maybe a customer isn't that educated and you can help them understand why are we using the spec? Or maybe they want you to use a spec and you don't believe that's the correct specification, that another specification is more appropriate. And why do you want to use that? You get the terms and conditions from a customer and they'd say, well, we want you to use this spec. And you say, no, we don't follow that spec because we have this system and it does these things and are recorded. And I at a moment's notice can look that up where this spec doesn't give me that kind of visibility. So being in part of specifications covers that and helps you understand it more fully.
Yeah, and I think it also it gives you and your company a voice too in what the specifications will be and where the industry will go, right? So you can be involved in shaping what the trends are, what is accepted and not accepted, and you can make sure that these standards are consistent with what you're trying to do as a company.
And
right?
that highlights a point, Gail, that you don't always vote yes. I have voted no on several industry specifications. The one that comes to mind is the IPC 7095, the BGA guideline. And in there, at one point in its evolution, it said the soldered joint workmanship criteria is. And I said, that's not correct. So the criteria is in J Standard 1 and 610. This is a guideline. It cannot have workmanship criteria. If the committee wants that, it should be over in the, bring that material over to the other committee. And they said, no, we don't want to. I said, fine, I'm voting no. And again, one company can't stop the publication of a document. I understand that, that's fair. But what would happen then is when a customer would come in and say, we want you to use portions of 795. And I said, no. I said, what do you mean no? And I said, we are on record as voting no for these reasons, because we believe this is the status. And the customer will go, oh, okay, we didn't know that. And so, again, being involved in the committee allows you to do things and work through. As it turns out, in the next rev of 7095, the committee looked at that and said, yeah, you're making a strong argument. We should change this around. And that information went over to J Standard 1610, was no longer there. There were guidelines on suggestions, but the hard criteria was in the other specifications. And just that interaction of working with people was fun. I learned a lot doing that.
So you say that working with people is fun. I wonder if working with these organizations can sometimes be challenging, and if you have any great stories of epic battles in meetings and how they were overcome.
I don't know if I'd say epic battles, but there are times, and I laugh because now as retired, I'm doing a little bit of consulting. I'm 99.6% retired, only consulting when it's fun. And you'll get a customer or a client, someone bring in a consultant, and that consultant will say, well, you can't use lead-free because it's garbage. It won't work in our environment. And you look at it and say, wow, that was 10 years ago. Where have you been? But you can't tell the consultant that. You can't tell the customer they have a consultant that is severely out of space and time for the most current and new information. That's always fun. The beauty, I think maybe if I think about an epic battle, there are times in committee that we argue about the word "the," and I'm thinking, really, we're going to spend 10 minutes arguing about the word "the"? How is this not technical? Or, we're arguing about using component versus device. But then again, you got to remember, we, in most of the committees, we're speaking English. We translate these documents. Does device and component translate in Spanish or Russian or German the same way? We don't think about it, but these committees, these specifications are for global use. And so you've got to think outside the box a little bit. And sometimes the wordsmithing, which seems arcane and silly, and why are we doing all this, is very important, because the technical idea that you want brought across will depend on how it is documented, how it is spoken, how it is written. And to be a global enterprise, which is what we want out of our standards and specifications, they need to reflect that. And so there have been times when most of us are just like completely fed up and just do it in English. And nope, sorry, as much as you want, it has to be global. And so we have to endure those discussions. In the end, we get a document that is much better and works for everybody.
Yeah, and I know the language has to be very precise because, like you were talking before, between guidelines and a specification, those are not the same thing. And so you have to be able to differentiate between when something is required or suggested or best practice or, more important and needs to be sort of nailed down, right?
I'm learning in retirement, you got to do things. So I'm learning Spanish. And Las Niñas can mean the girls or can mean the children. Okay, those are two different meanings. And that's just because different languages do different things with how they're put together. So absolutely, we just got to take in consideration, we want to be fair and understand how that may translate. And so our meaning gets translated correctly instead of going down some rabbit hole and not meaning what we meant.
Yeah. So do you have any good stories that illustrate the impact that SMTA and IPC have had either on your career or the industry as a whole?
You can split that into two buckets. If I look at IPC, becoming a chair taught me how to, and we've said this before, but engineering's easy, people are hard. How someone brings a silly idea to a committee, and how do you tactfully tell them it's a silly idea respectfully? How do you got to be professional about it? How, if they have no data, how do you talk about that? What if it's an idea that data supports but you don't endorse as a chair? Okay, you've got to, I'm one vote on the committee. How do you deal with that? How do you manage time? How do you get agendas out? How do you do schedules? As engineers, we do that on projects, but to do it across a whole committee, something industry about people that I just can't walk down the hallway and say, hey, we're going to change the meeting time. Okay, how do you get all that coordinated? I knew none of that. I was just an engineer doing projects. I was just testing materials. And so to do that and do it so it was beneficial and efficient and didn't waste time was huge. And IPC taught me that. IPC taught me how to be consistent and repetitive. How do we bring data into specifications without biasing things? Because the standards are supposed to treat us all equally. If I flip over to the SMTA, presentations, we get presentations, ideally every year. My first tutorial that I put up there, it must have been horrible. I have no doubt that people hated it because I was learning, how do I take 3 hours of time and talk about a topic? And how do I break up and make it interesting? How do I not put them to sleep? How do you organize this? How many cells do you need for 3 hours? Even if you're going to take a bio break in the middle. So it taught me how to put together long presentations about a topic with relevant data. My mentors have said, you realize people come to these tutorials and they've paid money. And I won't name names, but I have been to tutorials where I get presentation cells that say nothing. There's 3 sentences. There's no pictures. I can't take this back and give it to my management. I mean, I learned things out of the tutorial, but none of it's written down. And I get that. And and I struggle with that a little bit now as a consultant. Like, are you giving away your knowledge? But isn't that what those participants paid for? And I think it's better to put that information down, list the references where you get. I have been very privileged. I can call up many of my industry buddies and say, hey, excuse me, I want to use one of your cells. If I give you credit that this came from you and you developed, can I have permission to do that? And say, absolutely. Just make sure I get credit for where it came from, so they realize that wasn't your cell. And that makes it easier to illustrate different ideas when you may not have a very good example. But like Dale Lee, who is a master at producibility, can show you why maybe a teardrop pad is better than a square pad. I don't have any good data, but Dale has something, so I can take that one cell and help illustrate it. So SMTA taught me how to put together full-on tutorial technical things. Also taught me how to be a better presenter. Taught me on some, how do you make sure that your cells are the right font? How do you not read your cells and present your cells? How many pictures to text? How can you balance a presentation and make sure that the audience, because most of us read a cell in about 20 seconds. I can read through 5 or 6 bullets. Is there anything else there to catch my eye? Do I have them looking at a picture? Do I have a different question for them to do things? So, SMTA has been a wonderful experience in teaching me those skills and allowing me to be a better engineer because of it.
Yeah, I like a lot of what you said. So it's interesting how, just working as an engineer, you can just very much get down into the nitty gritty of the technical stuff that is your friend. But things don't get developed, ideas don't get shared if people can't communicate, right? And so you have to be able to communicate your ideas. And then in those committee meetings, you want people to ask the questions, to throw out suggestions. So if you shut them down, they're never going to do that again.
And you might miss out. Yeah, absolutely.
Exactly.
That's very important what you bring up.
And I know, I remember back at IPC Apex, I was in one of the IPC meetings that you were in, and people were trying to get participants, volunteers to participate in something. And nobody would raise their hand. All the new people in the industry were just like terrified of committing to something. But what would you say to those young engineers and newcomers in the field about why they should raise their hand, why they should get involved, and how not to be afraid of taking that step?
So number one, you don't learn but without trying. So try. So volunteer, but volunteer for a small piece. Don't volunteer, I'm going to read the whole chapter. Say, hey, I can go get, you want to know what type of analytical equipment we can use to analyze solder. I can go after that. I can come back with a small paragraph or a list of equipments. Start small. I did the first committee. I volunteered to write on one topic in one chapter, and that went really well. So I thought, okay, they accepted that. We tweaked a few words. Maybe I can help with a chapter, or maybe I can do this. Once you're immersed, then you might be able to, you and I might team up together to go work on J Standard 6 solder spec. We're going to add something to it. So I can learn from your writing, and I can see how your thing you put together. And that makes me a better engineer by just collaboration. So you start small and grow as far as you want to take it.
Yeah, so take that initial step, right? And I think recognizing that you have agency, right? You have the ability to participate and say things and do stuff like a real human. You're not just there as some sort of background character in SMTA or IPC. You are SMTA and IPC if you are a member, right?
Exactly. You are part of
it comes together.
And you should participate and be part of the solution.
Yeah. All right. Well, I have one final question I want to ask you before we wrap this up. I keep hearing about your kayaking adventures. So I want to know, how did you get involved in kayaking and what drew you to it, and how much kayaking have you been doing lately?
Lately, I've been doing none. I had quadruple bypass surgery and they can't lift 5 pounds. So I'm on the injured reserve list until this fall. But yeah, I have been boating for 47 years, started back in 77. I've raced, I do flat water. I've been in canoes, I've been in kayaks. I got started because I asked my parents I can buy a motorcycle or I can buy a kayak, because I had enough money saved up over summer jobs. And surprisingly, they thought a kayak was way better than a motorcycle. And so I got into boating, went to Iowa State, learned how to do whitewater. I'm now American Canoe Association level 4, class 4. I do class 4 or 5 whitewater. I do some of the tough stuff. But I've also I have gills. I've outriggered in the ocean. I've done wave boards. In 2022, I started at the headwaters of the Missouri River in Three Forks, Montana. And 4 months later, I put my hand on the Gulf of Mexico. So I spent 4 months going down the entire length of the Missouri to its confluence of the Mississippi, and then paddled the rest of the way down. So I think water dissolves stress, and I think we all should have hobbies that allow us to relax. And I think you see a lot of technical people drawn to kayaking and paddling. And part of that is it's a technical problem. When you look at a section of water, how should you go through it? What should you avoid? What is the puzzle? And how do you deal with the puzzle? And so a lot of my friends are engineers that I paddle with, medical technicians, professors, people in the technical fields that water allows them to relax. And yet it somehow
Yet they could
wiggles.
still be a nerd at the same time.
Yeah, it wiggles that technical thing, exactly. And they have a lot of fun doing it. I mean, we'll stand above a rapid and say, well, who's doing what line? Well, why are you doing that line? What? And it feeds that engineering mindset very well. So, and I have a lot of fun doing it, meet a lot of different people, see a lot, I've paddled all over the US, been to Costa Rica, paddled in Spain, paddled in Europe. So you get to see parts of the world at the same time. So it's a lot of fun.
Awesome. We hope you enjoyed this episode of Industry Insights with Ames Solder. Don't forget to subscribe to our channel and follow us on social media for updates and new content, or visit amessolder.com to learn more.